All right. So chapter 1, of course, was intensely fun, but there were no formulas in it. Chapter 1 was ordinal, nominal, stratified, all that kind of shit. Chapter 2, we eventually got to some formulas. The first real formula we hit that I'm allowing you to put down is this, but I don't know why you would. Of course, it's the exact same formula, just for a sample, right? So it's up to you. If I was you, I might not even write that down. And I'm not going to make you do the standard deviation, the x minus x bar squared divided by n minus 1, then sum that, right? I'm not going to make you do that. I told you that. You're going to do that in 1 bar stats now. Cool. So it's sort of like that females and males problem on the last test, where you had 2 lists of data. You just have to put them in a list 1, list 2, get the 1 bar stats, get the x bar, get the s. I like it. Okay. They do kind of do. Of course, this we should know really well by now, right? And it goes along with this dude. Can somebody give me a situation where you would use this formula here?
You have a z-score where you find an x.
Yeah, basically. But more specific, what situation? Give me like a problem I might give you.
Probability of
So that would be this.
percentile or
Percentile. Sure. If I tell you the percentile, find the percentile shoe size. All right, we look at the percentage, get the z-score, plug it in the formula, figure out what the raw score is, the shoe size. I like it. So if I say find the score that puts you in the top 5%, that's going to be this eventually. Figure out the z-score, and then go that many standard deviations from the mean. That's going to get you to the data point. That is that. Okay, maybe. Real quick, if I said top 5%, will the z-score be negative or positive? Top 5% positive, right? So if you look at 0.05, you're going to get a negative z-score, but you should stop yourself and go, well, I know it's not negative. It's the top freaking 5%. I don't want to go down from the mean. I don't want to go up from the mean, right? For the top 5%. Okay, maybe. Then we get to chapter 3, a bunch of probability stuff. Of course, OR is basically add. Why do I say basically? Because you're going to have this adjustment. And is basically multiply. Why do I say basically? Because this might be different from the probability of B. Right? A might affect B. If A does affect B, that of course would be what kind of events? If the probability of B given A is not equal to what the probability of B used to be. If A affects B, dependent, because then the probability of B depends on if A happened or not. We actually got the wording of that correct. It's pretty good for us math people. Okay, I like it. And then this is the one that freaks people out. And is basically multiply. So when I look at this, I see this as probability of A times probability of B. That's how I see it. Given A, okay, but it's still the probability of B in that situation. And this is still probability of A times probability of B. It's the same formula, it's just, it doesn't matter which way you do it. Okay. Then we get to chapter 4. Chapter 4 was the P of X stuff. I don't know which way you want to do it. You could do sigma squared equals that, or you could do sigma equals the big ass square root of all that shit, right? Just don't forget to square root. Otherwise you got the variance, not the standard deviation. So that was the first part of chapter 4. Then we got into binomial stuff. That should look very familiar. And then we got the best mean and the best standard deviation formula ever. Okay. Then we got into chapter 5 was uniform stuff. No real formulas there. Chapter 6 was where we did true z-score problems, normal distributions. So we've already got the z-score formula up there, but I mean, if you want to, you can put it again. You can even put it in terms of sample stuff. Then you can do this one. You can even remind yourself that the formula still works even if it's just S. Yeah, I like that. Mikey. That's chapter 6. Running out of room. Gonna have to erase some stuff. Let's see, I can use that a little bit. Then we have chapter 7. Actually, this is 6 and 7. I think this is in chapter 7, central limit theorem. Chapter 8 is where we do confidence intervals. And there's going to be 5 of those formulas. There's going to be 2 X bar formulas. And then 1 p hat formula. Holy crap. Calm me down, Z. And then you got a couple of formulas if you want to know how big of a sample you have to take to be within so much. The bigger your sample, the smaller your error should be. That's really what that formula says. That's for percentages. So those are the 5 formulas from the confidence interval stuff. So really, if I was you, I'm like keeping track of which things sounded the least familiar. Maybe that's something I make sure that I go back and look at. We're not done yet, by the way. I gotta erase some stuff. That's chapter 8. I'm gonna erase this early stuff. Is that all right? Then we get into your favorite ever chapter, the hypothesis testing. You got it. I mean, if you want to, you've got this thing on your formula sheet now several times. Yeah, you want to write it down again. Then you got the one that was kind of new to us with the p hat stuff in it. P hat minus p. Notice how these are not added. Let's see. You got the one from section 10.2. If you did that extra credit, you can write that down in your formula sheet. Then you got linear correlation. There's no formulas to write. That's all done in the calculator. And then you got chi-square. The only one we're going to do is this goodness of fit. T star. Yeah, in fact, if you want to, it's a good idea. You can do this. I mean, several places on the formula sheet it's reminding you S means T, sigma means Z. As long as I know that it's normal. Right? So you have a couple places in the formula sheet that try to remind you why T scores were invented. They're invented when I only know S. Yeah, very all right. Yes.
How do we know what to use p-hat again? The p-hat for z-speed?
So what's the real question?
Like, okay, so you know how there's two z-score functions? How
Yes.
do we know when to use it over the p-hat?
When you have percentages.
Percentages, okay.
Yeah.
I forget.
That's a big giveaway, right? Sometimes people will try to force a percentage problem in here and they'll say, I can't do this, Mr. Waller, you never gave me a sigma. I'm like, I didn't need to. It's this kind of problem. So if it's a percentage, if I say test the claim that the percentage, oh, screw this, I'm going to use this one, the one that has places for percentages to go. Right? You guys with me? Who's with me? None of us. Sure. Alright. So, it might be a good idea, if you look through this little outline, make sure you know where the formulas kind of fall in the ideas. Anybody have a formula they want to suggest that they could put on their sheet beyond what I put up here already? Now's the time, because otherwise it's not legal. Yes?
I know it's just the inverse of one that's already on here, but can we put P of B given A is equals PA and B
Oh, sure.
over?
Yeah. So earlier I had P of A given B. So you could certainly put on there P of B given A, sure. So you can add this formula in there too. Hopefully somebody out there recognizes they're both the same formula. What would probability of F given G be? It would be F and G divided by P of G. So in mathematics, the symbol we use to represent an idea doesn't itself matter. Why do we use X and Y? Because sometime back in history we said, let's always use X and Y. Could have been C and D. Could have been W for Waller and J for Jeff. I don't know. I didn't live back then, so didn't even have a vote. All right. So now it's pretty much wide open. I've got a sheet of examples of z-score problems, and on the other side is like a chi-square and a correlation problem. So I mean, we could do those. We could do problems off the practice final itself. I do have that answer key that I'll give you eventually. Oh, before I forget, let's do this. I did not put number 11 on the key because I'm lazy. I ran out of room. I just didn't want it. So why don't we do number 11 together? So everybody, if you want to, try number 11 on the practice final. gonna stop on?
I may.
During the break, just remind me as I walk out the door to change it. Yeah, if we take a break. By the way, if you don't need to work on some problem that I'm trying to make everybody kind of do, you can work on whatever you want. You can work on quiz corrections. You can work on any corrections you haven't done yet, right? If you didn't do test 1 corrections, do them. Holy shit. Those tests are worth a decent chunk of your grade. So any points you get back is going to be a boost. We're trying out number 11 on the practice funnel. See who's alive. Sit down and change his batteries out someday. Yeah. Push it together. Just to make sure everybody's on the right track with this one. What goes in this column here? Yeah, so right here I put 51 because I observed 51 A's and like, and then so that column is easy. And if you just look at this column, does it look like it might be normal? Starts low, goes up, goes back down. It looks roughly normal. So this test is really to see, is it normal enough? To make sure everybody, how would you figure out what goes here?
You do what
3.3 times 142.
I like it. We expect 13% of any group of students to get A's. That's our expectation. So I'd do 0.13 times 342, and you should get, I like it, 44.46. Do that for all those using the percentages. So if they don't give you percentages or give you expectations, then more than likely it's a uniform problem, uniformly distributed. So are you guys getting those numbers for your last column? Oh shit. You cannot see them. There they are. Right. How about these? If you're, are you getting these? Observed minus expected squared? Yes? I like it. So then all I did to get this one was I divided L3 by L2. Divide that by the expected to get a relative feel for how big the difference is. Cool. So nobody's speaking up about different stuff. So how do I get my chi-square? We haven't got the rejection chi-square yet. We're going to do that second. How do I get my chi-square?
Sum of L4.
Good. Sum up L4. So if I quit, I can go to list, math, sum up L4, 5.535.
Yeah.
Which I can't say, you would say that's not very far away from 0, but we don't know. You have to look up in the chi-square chart to see what distance away is evidence. So what do I need to look up in the chart? I know that alpha is what?
0.05.
0.05. Degrees of freedom is what? 4. All right, 5 categories minus 1. So if you look that up, what do you get for a chi-square?
9.8.
Yeah, 9.488. So that's where evidence starts, that it's different enough. So if I wanted to draw this out, little Jabba the Hutt, wow. So it'd have to be at 9 point, I forgot it already. What was it, 348?
488.
488? Thank you. And we only got to 5.535. So we didn't make it in there. And again, try not to memorize phrases. 0 would mean no difference. This is where evidence begins that shows a difference. So have we found evidence that there's a difference? Have we found evidence that they don't follow the pattern? Nope, we didn't. We didn't make it far enough away to say there's a difference.
How'd you find it on the chart?
Ah,
Sorry.
so you cool with alpha's 0.05?
Yeah.
Degrees of freedom is 4, right? You guys all cool with that or no? It's okay if you're not. I could go insane temporarily.
Why is it 4?
How many categories are there?
Okay. some reason I was looking at like the number of students.
And I don't blame you, because we're used to degrees of freedom for other problems, but for
Right.
chi-square, for goodness of fit problems, this is one place we see the degrees of freedom idea changes a little bit. It's based
Okay.
on the number of categories.
Okay.
I like it. All right. So that's how we got
Okay, I see.
there. 9488. So that's where evidence begins. If I get past that, that's so different from 0 that there must be a difference. Or there's a good chance there's a difference. But we didn't make it that far, so we haven't found evidence. So is there evidence this group does not follow? No. And that kind of jives with what we saw just looking at the data. It looked roughly normal. And I told you that this was going to be like a test for normality. That's kind of like the percentages we use for 5 categories to test for normality. So we didn't find evidence that it's not normal. It looks like it is is normally distributed. Okay, maybe. We didn't prove it's normal. We didn't prove shit. But we found really good evidence. We didn't find evidence to say it ain't. That's the way to say it. Yeah, we didn't find enough evidence to say that it isn't innocent. All right. So that one I just wanted to do because I didn't put it on the answer key. The rest of them are on the answer key. What do you guys want to look at next? Anything? And if nothing really specific, I can give out these little worksheets we can work on. Yes? Oh yeah, all right, this is the one where it doesn't add up, right?
Yeah.
So for some reason, the people that made this book decided, one thing is realize it keeps going up here. So if you haven't done this problem, I'm not gonna read it to you, but if you get to this problem, the percentages actually don't add up to 100%. They left something out. They add to like 98.9%, which is kind of far enough away from 100% to be worried. But, and that's always a good check to take. So they didn't do that, but you still just go ahead and do the test. Yeah. So there's some category they left off or something.
So I was like doing the one, I did like, the L1 to L2 doesn't on the last one, the O to the second divided by E. I got the real big number for the first one.
Yeah, well so 11%, and how many, there's 5,000? You did? Right, so 11% is 550. So that would be 2,500?
Yes, I did like the 2,500, then I divided it by E and I got 22727. It was a crazy ass number.
All right, be careful. What your expected was 550. So you're going to divide 2,500 by 550. Yeah. Yeah, the percentages actually shouldn't show up in your table at all. It sounded like you divided by, well, I don't know what you divided by, to be honest, but okay. So look what they do. I try not to do this to you, but this is an acceptable way to give information. What should be here? Not percentages, but pure numbers. So you don't put these numbers in your calculator unless you want to try to use them to calculate. But I've got to do 11% of 5,000, 6.7% of 5,000, because there's 5,000 total people if you add them all up. Just like the problem we just did. It's just that I put the percentages in a separate little table. They put the percentages all together in one table. Just to really make sure you guys understand. I shouldn't put 11% here in my calculator. I should put 11% of 5,000, which is 550. Do that every single one. That's what you put in the calculator. And see, 550 is not very far away from 600, relatively. Okay. Love you guys. No reaction. I can't gauge anything. Do they understand or not? I have no idea. Okay.
Remember some like confidence interval stuff? 'Cause
Sure.
I feel like
Okay. What kind? Yeah, there's. Let's see, what's on this sucker? already?
7.
Oh, 7. Am I asking you to create a confidence interval number 7? Yeah, I'm trying to find it. Given a normal, how large of a cell? Okay, so I need the formula that solved for n. So now, so what would that formula be that I need to use? It's up there on the board. So I'm trying to figure out how large a sample I need. And I'm given a standard deviation of a population. I'm given how confident I am. I'm given within 3. So which formula am I going to use? Are there number 7?
C squared.
Yeah.
Alpha squared.
6c squared, sigma squared, over e squared, right? Because they tell me e. What's e? They just tell it to me.
3.
3. I want to be within 3. I want my error to be 3. They tell me sigma. How do I know this is sigma?
Population.
Freaking population, yeah. And then how do I figure